we are going to consider a new topic called as trusses. Actually, truss is something that is our everyday's observation. Like in our workshop, when we look at the ceiling, you will find that the ceiling is made in the form of some members which are welded together or riveted together, and this is how the particular top of that particular building will look like. You must have observed such a thing, or even in civil engineering you might have learned this type of roofing, something of this sort. And all the members which you are going to have over here, these are called as the trusses. Now this truss is going to carry some load, and it will be even supported also. It will be hinged at the points, and there could be some load which will be acting onto it. Even for some bridges, etc., we can see the similar structure. So when we talk of the truss, we will say that it is made of several members. It is made up of several members which are pin connected to each other. These are pin connected members, we say. And a typical truss may look like something in this form. So it may appear somewhat in this manner also, and there could be some support on one side which could be hinged. At the other side there could be roller present. This is to cater the loading, to support the loading which might be there on the particular truss. Now these members, these are all the individual members of that particular truss. These are the pin connected members, and each member is going to carry some load. Now when we talk about the load, then the load on a particular rigid member, can be the load which is acting in this manner. One thing is to be accepted at this point, that as these members are going to be in equilibrium, the forces which are going to act on that particular member are going to be the axial forces along the length of that particular member, and they will be equal in magnitude and opposite in direction. Then and then only the equilibrium will be achieved. Now these two forces, as I have shown over here, are going to compress that rigid member. So we call this as a compressive load, or the member is in compression. So compressive load. Now this whole member is in compression. So if we are to show the internal forces, because what we have shown just now are the external forces acting on that member, internally assume the equilibrium of this left end, then there will be internal force which will be supporting that of the same magnitude, opposite in direction. Similarly at the other end, there will be the same magnitude force but opposite in direction. So this is what we will be calling it as the compressive load. But at the same time, some of the members, they might be having the equilibrium, but the external forces acting on them could be the pulling forces. Again, the member will be in equilibrium. These forces will be axial forces, equal in magnitude, opposite in direction. Such a force is called as the tension, or the member is in tension, we say here. So these are tensile forces. Now internally, when we try to show these forces, obviously they will be shown in this manner. Now what I have shown over here, these are the external forces, and this is the internal force. Again, this is external force, and this is internal. In other words, I can say that if all the members are in compression, then the internal forces will be acting towards the end, and if the member is in tension, then the particular internal force will be acting away from it. So these are the members which we are talking of over here. This is one member, this could be another member, this is the third member, and so on. For the stability of the particular truss, it should not be having anything which is in the form of a quadrilateral. Say something like this cannot be there, because you will find that this is not a stable structure. You can uniquely define a triangle just by defining the sides, but you cannot uniquely define or constrain the quadrilateral. So you will find that in truss, everywhere the members are forming the triangles with each other. These members, three members will come together to form a triangle. There will not be any other shape which will be coming into picture. Now these members could be in tension or compression. It will depend on what exactly is the force which is supported by them.